Righty, right. Cool. I hope people who went to the HTML CSS class appreciated it. I think it's awesome that we have that. And I'm sure you guys are going to get awesome instruction from Chris. I know him. He does an amazing job with the stuff that he does. He's collaborated with me before on some of the other coursework, so I'm sure it's going to be great. What I will say with that is that did pivot a little bit in terms of what I was planning on building off of today. And so today's class might be a little shorter. I wanted to present a little more for this topic, so I might still keep working on it, but this is also the first time I've presented this material, unlike pretty much everything you guys saw in the basics class, which we've sort of gone over before with other students. So I'm going to be really interested in the feedback of how this specific class goes. Just let me know it when we're done if you think that it was a help for you. But what I wanted to get at least one class session in on was just getting some tips for learning how to solve programming problems. I think that this can be an obstacle that a lot of people have when they're just getting into programming, is they get really hung up on the problem itself and how do I break this down. And I've talked a little bit about how to do that in code, and you guys are going to see many more examples, but this is a higher level. This is more outside of any specific programming language. So this is about how do you figure out where you're going to start it all, and really just about any programming language, these same sort of rules could be applied with. And I think the first thing that I don't hear enough talked about when we talk about this is that most of the programming problems that you're going to encounter, especially when you're just learning how to write code, have a very strong similarity to math word problems. And this is no coincidence. This is pretty much the result of it's much easier to explain stuff with word problems than it is otherwise, because that's a spoken language and we can understand it. But it also is because computer science and programming came out of math. A lot of the early programmers were mathematicians and have evolved from that sort of skill set. And so it's got a very strong heritage around this math aspect. So that means that there's going to be similarities both in the types of problems we have and in the sort of tools that you can use to try and solve them. So I don't know if people remember, but word problems in math, and I'm going to show some examples in a minute. But the key is many of the same strategies can be used to solve these programming problems. So let's go ahead and revisit math word problems for a little while. We're going to go back to our school days and revisit some of these types of word problems that we would have encountered. Maybe some of you really hated them. Maybe some of you liked them. I don't know. But we're going to look at a few of them and just talk about what some of the tools are that you use to solve those. And then carry that same set of tools over into what we'll do for programming problems as well. So let's look at word problems for math and what type of tools you would use to help solve them. I think the first one that gets emphasized repeatedly, right, is you need to read the word problem carefully. And you need to read it carefully because there's a lot of little things in there that may trip you up. There might be intentionally misleading words, or there may be things that say, negate a value, like not this. There may be words that typically mean one thing, but because of the way that the word problem is written, it means something different in the context that you're working in. So you really need to be careful as you're reading through it. And while you're reading through it carefully, you want to ask yourself, what is being asked? Like, what's the result that's being asked for from this problem? That's probably the first thing that you want to identify when you're trying to solve some sort of word problem. What am I trying to get out of this? And then you want to look at it, and I'm sure people have practice with this stuff like markup, or whether you do it in your head, whether you do it on paper somewhere, mark up the relevant information and then ignore the irrelevant information. That's the challenge with the word problem, right? Is there's a lot of text in there that's giving you context, that's giving you color and flavor that really isn't relevant to solving the problem. And then you want to be able to break it down into the individual steps. Because especially, I mean, a lot of times when you're just learning word problems, it's like one step. Okay, there's one thing. But by the time you get to the more complex ones, there's several steps involved in solving a word problem. And that's the same case for a programming problem is figure out what the information is, figure out what you need, figure out what's being asked, and then start figuring out what are the individual steps that we need to break this down into. So let's take a look at some, and let's just talk about, how we're going to solve these. Feel free to post stuff in chat about things that you notice in them. I might pause on them for a moment to give people a chance to say what tips or tricks they have for solving these. And yes, some of these are, and really these are all very simple examples. I'm not trying to give you incredibly complex, tricky word problems here. I'm just trying to give an example of something that hopefully everyone's familiar with so that it helps you when you're solving programming problems. One of the reasons I wanted to go over this earlier before we really start doing some more stuff is now that we're going to be focused a lot more on solving these sort of more complex programming problems, you're really going to need to emphasize these skill sets, the skill of how do I read this problem, how do I break it down. So if we start with this one, which is, there was a nest of fish eggs in Brookfield River. 302 of the eggs hatched and 114 of them didn't. How many eggs were there in total? Are there any thing that jumps out at people as you're reading that say, here's the important information, or here's something that indicates how I would want to solve this? Because there's definitely some bits of this that become these sort of patterns, these tricks, these tools that you want to use. Anybody have anything? I mean, I've got plenty on here. I know this is pretty simple stuff for the most part, but any things that jump out at you as indicating certain stuff? No audio. Okay. Whew. I was worried. Look at my patience. See, I've got this whole other computer that I have Slack up on, and that way I can see that people are typing and then they quit typing, or they're typing and they quit typing. So I get to see people trying to think about saying something and then not say something. Right, numbers. Okay, you added them up. Was there anything that said why you should add, right? There's something that indicates add. So total sort of suggested addition, right? That's one of those things that you sort of learn when you're learning word problems in elementary school is, oh, certain words have certain meanings. Oh, I see total, that probably means addition or something along those lines. And then, yeah, I see these numbers, these relevant bits of information. And then you've got all this stuff that really isn't that relevant. There was a nest of fish eggs hatching and stuff. Like a fair bit of that isn't that relevant. But you've got the things that are sort of important to pull out of that, right? So let's look at just a couple more examples of word problems. Hopefully, this isn't any sort of PTSD for people. You don't have any trauma from word problems in elementary or middle school, and you can look at this fine. But I know some people were really challenged by working word problems, right? So here's another one. Nothing too complex. As you read through it, as I read through it, feel free to say anything that jumps out as indicating certain things, right, that you notice while you're working it or reading it. So we've got Newberry Publishing needs to ship 48 new math textbooks to a high school. If each box can hold 8 textbooks, how many boxes will the publisher need? Right. So you've already jumped to a solution, but there's a lot of little things in there that indicate stuff, right? And I think that's the critical part is, as adults, we've sort of learned how to read something like this and solve it all in one step very easily. But the programming problems that you're encountering are very similar to this. And I think one of the challenges that people are having when they encounter this stuff is they think, oh, I'm going to take this programming problem and solve it all in one step. I've got everything I need to solve this. I'll just do it all at once. But the key is learning how to break it down and find the critical bits and do those one piece at a time. So what we've got here is, again, we've got relevant values, 8 and 48. And we've got like each. Up here it says if each box. Well, each, I mean, that indicates some sort of count maybe. So maybe it means multiplication or division, but we have to read this carefully to really figure out what that is in this context, right? It's not a instantaneous, okay, we know what this is. And then you've got ones that, oh wow, this is horrible. I don't know why the formatting ended up being this way. All right. Might have some weird stuff farther down on this slide. We'll see how it goes. But we have like, oh, it's because the dollar sign got interpreted wrong. So Eric saved $21 in March. He saved $19 in April and $30 in May. And then he spent $38 on a keyboard. How much money does he have left? And just like the other word problems, we've got certain things in here that jump out at us as indicating stuff, right? We have spent and left. That sort of suggests subtraction. I know this might seem very simple, very reductionist, but the point of this is to show that really this is the same tool set that you use when you're solving programming problems. And I don't see a lot of people necessarily present stuff that way. Yeah, writing down a map, I think, is a fantastic thing. Somebody said they find that writing down a map of what they need to program helps a lot. That's very true. In fact, that's one of the tips for word problems, right? Is map it out. Maybe draw something out. The same sort of thing applies to programming. That's why you've heard me talk a lot about write it out in plain text as comments and then figure out how to replace those comments with code. So we've got in this one, spent and left suggesting subtraction. We've got saved. Saved probably suggests addition somehow. And then we've got all these different numbers, right, that look relevant. So this one is multi-part. You're not going to solve it in one step. You're going to have to work over several different steps to solve this. And that's the case for most programming problems you're going to encounter. So let's take this same logic and let's start looking at where we get some patterns for programming problems. What is similar in code that tells us what tools we can use, what tricks that we have? So programming problems tend to follow the same rules for how to solve them. And that means you want to read them carefully. I mean, read them multiple times. Read them out loud if you need to. You want to figure out what is being asked. Like, what's my end result here? And what does that mean? There's some things I'm probably missing on this, but you want to identify like what data types am I probably going to be working with? Am I working with numbers? Am I working with arrays? Am I working with strings? Figure some of that stuff out. Start to identify what those are in your problem. And you might be working with multiple, right? What information is relevant and what doesn't matter? What's going to get translated into your code and what is not really applicable to the code? You want to know what stuff's irrelevant or misleading. This is very common in the programming problems you encounter. There's a lot of irrelevant and misleading information, a lot of things that are there to sort of send you down the wrong path. And then I added this one on this list, but it's what we are doing on some of the other ones. You want to identify the tools you might use to solve the problem. So what tools do you have that can help you solve this problem? And if we start looking at that, so let's look at this list here. We have each, every, iterate, count, all in a programming problem of some kind. And this is just a subset of it, but it's an example of the type of thing that you're looking for as you're working through these. All these words probably indicate that some form of, anybody want to take a guess, is probably going to be needed to solve this problem? and you're thinking of programming tools right now, not of math tools, but if you have these words in a problem, what might it indicate you're probably going to want to use? Yeah, some sort of, I have iteration listed here, or loop. Exactly. These words all sort of imply you're going to be doing something over and over. So that means, oh, it might be a for loop, it might be a while loop, it might be the for each method, some other way to iterate over stuff. But looping is sort of what jumps out here, right? And that's where you want to highlight that idea and go, oh, okay, they want me to do something every time. I need to loop over stuff in some way. I need to iterate through things. You'll probably hear me use the term iterate more than anything else. It's just more of a programmer term because you can iterate in other ways rather than looping. Looping is like one way to iterate, but there's other ways to iterate over stuff. But it's the same thing, right? And so you've got these tools, this toolbox that you can build up the same way that you solve word problems in math. Now, see, my conditional presentation stuff didn't work exactly as I wanted here. So let's try this one. If you encounter words like compare, if, only, when, test, what do you think that might indicate you want to do? Right. I mean, it sort of jumps out. You got an if statement, but more broadly, the answer is you want some sort of comparison going on. You want to compare values in some way. Usually, that's going to be an if else statement, but it might be the condition for a for loop or the condition for a while loop, or it might be some sort of other statement. We didn't really talk about switch statements, but that's another statement that might be similar. There's other ways you might solve that, but what you know is, okay, I need to do some sort of comparison. And it also, if you're thinking about data types, it probably implies, oh, there's going to be some sort of Boolean value, some true false that I'm checking against somewhere, right? That's what comparisons like if else use, is they need something that can be Boolean or that they can cast to a Boolean. But those are the types of things that jump out when you're seeing this, right? So let's take another one. Oh, again, this one cheats already. So if you see words, you see returns, you see outputs, you see input, takes, arguments, and these will probably be in just about everything. Maybe given is another good example of a term you might encounter. So these are usually going to indicate that you want to use a function or a method. Yeah, these are saying, oh, I have a function. It takes some sort of something. It has arguments. It returns something or outputs something. That's usually indicating some sort of function or method. And it also sort of implies what you want to do with it, right? So you want to be very careful because you don't want to, still encountering the issue where people are using, say, console log in a function to output something. In general, you should be thinking of most of your functions as the only way you get something out of a function is using the return statement. You never want anything to come out of your function, whether it's printed to the screen or otherwise, in a way outside of a return statement. That's true for most functions that you write. When you get to the very edge of your program, the outer portions, that's where you can use things like console log to output something, but usually returns or outputs, those imply returning a value out of your function, sending something back. So this isn't, it's not actually that complicated in a sense, right? Those are the same sorts of patterns that you use for these sorts of word problems that you encounter in school, Oh, it says some, or it says more, or increase by, or total, probably means addition. Or, oh, it says split, or half, or equally, probably means some sort of division, right? So you've got these words that you automatically apply to say, oh, that means I need to use this tool in math. That same stuff applies when you're encountering problems in programming. And I think that's probably one of the things that a lot of people get challenged on early on, is just knowing what tool do I use in what context. But it's very similar to the same sorts of problems. And so practicing that, getting used to that, I think is a really useful thing. So we're going to do a few of these collectively as a class. Again, I apologize for this being so short today. And then I'm going to, after class, it'll probably be about half an hour later, because I need to put some good ones together, and it takes a little bit of time finding good examples of stuff that maybe require you to break them down multiple ways. But after class, I'm going to send out maybe another 10 that I want you to not actually try and solve. Some of them might be beyond what you feel comfortable trying to code up, but maybe you do want to try and code them up. I don't know. But I want you to look at them and sort of jot down what tools you would use to solve them, how you would, what different tools in your arsenal you would use, things that you would use to try and come up with a solution. Because it's really important to practice that process even before you get into the coding. So I don't want people to feel intimidated to say, oh, I have to code up these problems. No, this is about thinking about how to break stuff down today. And that way, as you encounter these more complex ones that we're going to encounter, you're going to be able to use that same logic to break them down. So let's start with one here. And none of these are particularly complicated that we're going to go over right here in class. The ones that I send out for the homework, they'll probably be a little more complex, so you'll have to read them carefully, put multiple things together, etc. But again, remember, you're not actually writing the code, just trying to figure out what tools you would use for the different portions. So let's start with this one. Given a list of numbers, return the largest number in the list. What do you think? What tools are we going to use? What things are we going to use to help try and solve this problem that we know about from class so far? And in particular, say like what words in this description are indicating to you why you would use that tool when you're saying a tool. So if you say like, oh, we should use a function, what indicates a function? Or a loop, what indicates a loop, etc. Right, I see array. Why an array? List, right? List indicates the array. All right. I saw a for loop. What indicates the for loop portion as well? There's a lot of great built-in functions. Somebody said there's a built-in function for this on Slack. Yeah, there's a lot of fantastic built-in functions. The problem is most of the beginning programming problems that you're going to encounter in any sort of class have already been replaced by built-in functions, because they're so handy and so common that it's useful to just use the built-in function. But that doesn't mean that you're not going to be made to write them in some class somewhere to get that practice. Right. For loop, because we're looking for the largest, and also just because we have a list. That doesn't always mean a for loop, but it means something like it probably. And I like function. I mean, you'll hear me say that pretty much all problems that you're going to encounter should be solved with functions. I think your life is much better right now at the level you're at if you're thinking about breaking stuff down into small functions that you compose together. I think that is probably, I mean, I know I'm going through these sort of word problems, but if I were to give you my number one tip for being able to grow as a programmer beyond the very basics, is learning how to break stuff down into very small functions and compose larger bits of code out of those small functions. I think that if you can learn how to break stuff down that way and just to make small functions and build stuff up out of those, then you will be able to solve just about any problem you encounter in your career as a programmer, because that is probably one of the most fundamental tools. Right, return. So let's look at another one, right? All of these are, again, pretty basic, pretty simple, pretty standard. Let's say given two numbers, return true if they have the same value and false otherwise. This one's really simple, but it's sort of intentionally that way. What tools would we use, and why does this word problem indicate using those tools, right? Yeah, function. Yes, comparing. There's a comparison occurring, right? And so that probably means like an if else statement, but it definitely means comparison, no matter what. Exactly. And we've got function. This one's very contrived, right? I mean, there's not a lot there. Now we've got, again, and these are just very contrived examples to practice this. The ones I send out tonight will probably be a little more complex or sort of build up in complexity. And if you guys have other great ideas for the tools, how to realize what tool you want to use in different contexts, feel free to share that in chat too. Like, oh, this in a problem usually indicates I'm trying to solve it this specific way. All right, so this one's another. I mean, again, these are pretty contrived today, but it's a little hard to do uncontrived ones when you're doing stuff remote and you're interacting this sort of slow way. It would be easier to do more complex ones if we were in person because I can hear you guys shout stuff out. It goes a lot faster. When you're remote, there's this long delay that makes it harder. So given a list of prices, compute the total of all of the prices, right? What sort of tools are we using here? Again, same. And you guys can list tools other than the ones that I mentioned, right? It doesn't have to be an if, an else, a for loop. I saw for each. I mean, that's a great example of something else. I saw a function. Maybe there's an example of object. There's certain things that might indicate, oh, I probably want to use an object to solve this. In fact, I think I'll probably have some of those in the homework. Will be some of the problems will indicate that an object would be the best way to solve it. So what helps you figure that out, right? Right, we've got some sort of array going on, exactly, because of the list. We've got some sort of for loop because we're computing like the total of everything in this list. Exactly, right? Nothing too complex here. But now we get one that maybe flips the problem. Like maybe this is a little different than what you were thinking. So given a number, return an array of each digit in the number. That's a little bit different. What tools are you going to use to help try and solve this problem? This is the type of problem where looking at the keywords and trying to figure out, wait, what do those probably indicate, will help you out a lot instead of thinking about just, oh man, that's a challenging problem to solve. If you look at some of those words and say, oh, does that indicate that I might be able to solve it using a specific tool? So when I say, and let me clarify on this problem, right? When I say given a number, I mean a number like 4,000 675. I want an array of each digit in that. So I want an array that has 4, 6, 7, and 5 in it as individual digits. What are the tools you might use to try and solve that? All right, what indicates a for loop in here to you? I like the suggestion, a for loop. What might indicate that you might use a for loop? You need to loop through the positions of digits in the number, split and add array in the same loop. Yeah. I mean, that's one way, one thing. To me, I see certain terms here that indicate it. I see each. If we go back up and look at our little cheat sheet and we say, oh, wait a minute, each, that probably indicates some sort of iteration, right? I'm iterating over something with each. So that means I need some sort of loop or way to iterate over stuff. So I didn't even have to. The great part there is, even though this problem looks much more complex than the other ones, or maybe you don't already know how to solve it because we haven't looked at a problem like this before, certain words here already say there's tools that I can leverage. Oh, I want to loop somehow. So that's, I don't know what that means, but there's some way I want to loop over something. And for any given loop, I mean, a little bit of a cheat here, but every loop has some sort of condition, right? So then you have to start saying, what's my conditional that I want? So that's a good problem, but you already, even without knowing exactly how to solve it, you can already start figuring out certain tools that you can leverage, right? You don't even have to have the details of, oh, how do I actually accomplish this thing? So here's another really good example. I think this might be the last one I have here for us to talk about today, but another one that maybe people don't feel comfortable writing the code for immediately, right? I think this is probably one that you should be pretty comfortable with soon, but if not yet, but let's say we have two lists. Given two lists, return a new list that has all of the items from each list alternating. So an example here is 1, 2, 3, and ABC would return 1A, 2B, 3C. So what tools do you think you would use to solve this problem? And what sort of indicates to you why you want to use those, right? Each equals loop through each list. Yeah, we need to do some sort of loop through each list, right? There's something indicating that we want to step through each one of these items. We want to create a new array of them. Like this might be a somewhat challenging problem. Ooh, concatenator.push to make a new array. Yes, we can do that. We need to be thinking though that we need to look at it again. That's that reading very carefully, right? Is we need to alternate. So we can't take everything from one array and push them onto another one. We have to take one step on each one at a time. So we're sort of alternating these steps in some way. And then, yeah, the alternating part is exactly right. It becomes a little bit of a new challenge, but you can still see tools. And so don't get hung up on the new unique parts of each problem. Start off with noticing the things that you already know how to use. Oh, I need a new list that has all the items from each list. There's a good chance, just seeing lists, that I probably want to use some sort of looping or some sort of iteration tool. I mean, there's going to be some challenges with that, but maybe I can just start with that. Maybe I start with just iterating over one of them and move on from there, right? Because if I know that I want to step through them this way, I can start leveraging, start with what I know, start with the small thing that I know, and then build from that. And I didn't emphasize it in this class because I was more focusing on sort of learning how to read these. But you also want to learn how to break these problems down. So this is a really good one for you guys. Right now, I would say this is a really good one for your level of skill and where you are. But what if, as you're sort of stepping through this, ask yourself, what's the simplest version of this problem that I could encounter? And it's probably simpler than you think. If you were to say, what are the simplest lists that I could pass into this? If this was a function that took two lists, what are the simplest lists that I could pass into it to give me a result? And what's my expected result? So what are the two simplest lists that could get passed into a function here? And what would I expect as a result? Any guesses? So what if our function took in two empty lists with no items in them? That's probably the simplest thing that you could pass in, right? There's not a simpler list than the empty list. And what would we expect to get back in that case? An empty list. So see, you're already making it more complicated. But the interesting thing is, even by having, like 1A, 2, even if we said like the simplest is passing in an array, like the two arrays, the first array just has 1 and the second array just has A, that's already a more complicated case. But the interesting thing about it is, even though that one's more complicated, it's much more likely for your code to not account for the empty list case than it is to not account for the one with the two items. Because you're not necessarily thinking about these very, the term that's used here, it's sort of interesting that it's used in programming because it's actually used in the right context as opposed to most other places where it's used inappropriately. But the term that would be used is like degenerate, because it means like the most simple, reduced, basic form of something. So that's sort of like that degenerate case, that super base case of something. And that's the one that you're likely to forget. But then if you step from that, again, you might say, oh, well, how do I solve this? If I'm breaking down a problem, trying to figure out how to solve this specific one, how do I solve this if I'm given an array, two arrays, and each one just has one item in it? I have 1 and I have A. The first array has 1, the second one has A. And how could I write code to solve that? And that might be really easy code to write. So honestly, maybe the first version of your function just solves them if they have one item in each array. And then maybe you say, okay, well, now what if I have 2 items in each array? And I write that. And now there's 3. And now you begin to see a pattern of what you probably are going to be wanting to do in your loop when you write a looped version of it that solves it generally. So that's also that important tool is don't try and solve the complicated problem first. Try and solve the simple problem first. Try and make it as simple as possible and solve it, and then build up from there. All right, let me check. Just double check. I don't have more specifically on here right now. Again, I'm going to be sending out a set of word problems for programming problems. What I want you to do is to go ahead and look at them and sort of break them down and say what tools you would use to solve them. You don't have to write the code. You have to say what tools would be used and why you think those would be the tools that you would use to solve them. And go ahead and, I'm not worried about people sort of cheating from each other. So after I send that out, especially because we don't have GitHub as a general class yet, feel free to post your answers right here in Slack with why. And then I encourage people to respond to that too and say, oh, I didn't notice that, or I would have used this different tool to solve that because of this other wording on the problem. No, in fact, I want you to not have any coding syntax at all. The goal here is to not talk about syntax, but to talk about these high-level tools. The only way, the only code-specific things are, imagine that you have some way to iterate. Imagine that you have some comparison tool. Imagine you have a function or method. Imagine you have objects. So those are the types of things that you should be thinking about, not necessarily in any given syntax of how you would solve it. Just say oh, this tool is used in this context. And because the problems that I'm going to post for a lot of them might be beyond what you feel comfortable solving just yet. And so if you try and get hung up on the JavaScript part of it, that may be your barrier to being able to break it down as a problem. And I want you to instead practice breaking stuff down as a problem. Because I can give you more complex problems to break down than I can give you problems to code yet. Your coding ability isn't yet at the same level as the ability to maybe break something down. And so this is moving along one part of your skill set a little faster than another portion of your skill set at this point. So I know this was a really short class again. I'm probably going to try and beef this up a little more, but please get feedback I think somebody's asking for feedback after class now. So please get feedback when that's requested. Also, for Thursday, if at all possible, please try and attend that in person because we have a guest, I believe John Little, who's going to be presenting on Git and GitHub and teaching you that material. My plan is not to do a separate class on Git or GitHub. I hope that this is enough for you guys to be able to work with these tools going forward, and everything that we do going forward in this class will either be done in REPL.IT or in GitHub. So I really encourage you to be there for that class so that you have the familiarity with that tool and you're able to continue working forward. Building that portfolio on GitHub or having stuff be able to be shared on GitHub is really just one of those base skills of a modern developer that you're going to need at some point if you want to keep progressing. And then look out on Slack, probably I'm guessing it'll take me about 30 minutes to put together a good list of exercises for you to work on for the homework for you to work on for this. All right, I'm gonna keep going for tonight, but let me know if you have any questions or any concerns, and that includes any of the material that we've done before. I know some of you continue to work on that HTML resume structure, so if you've got that done, continue working on that or post it or let's see it. Again, we're not going to focus as much on HTML and CSS in this class now that we've got the other course that's covering a lot of that material, but definitely, if you have questions or concerns or anything about what you already worked on, let me know. And I'll see you guys later.